Alright, back with some implicit differentiation second derivatives. I've just done the last one, question 5, but I've shifted the page on the right so that it appears underneath. It's pretty long, it's a marathon video. You can look at the working there, but it's probably worth watching the video as I step through it. Really hard question. If you can do that or you can follow it, you're doing really well. These ones, I reckon you've probably already got the question right if you've had a go at it. Maybe I'm being optimistic, we'll see. But the answer in the back of the book looks a little bit different to what you might expect, and I'll show you how we get to that. I'll do the first one. I reckon after that you'll probably understand the process and you'll be able to do the others, but I'm happy to go through some more if you want. Just say, yeah, pick another one, ask me to do that one as well, and we'll see how we go. But let's have a go just with, so this is question 4, but it's actually based on 2a. So let's have a look. So we've got to find dy dx if x squared plus y squared equals 25. And if you've done the exercise by now, we can leave out the working, and you know that for any circle, dy dx is always negative x over y. I should say for any circle centered at the origin. Let's not get too far ahead of ourselves. Yep, so that's the gradient there. Dy dx is negative x over y. I'm going to assume you did that in question 2. So let's have a look at how I find the second derivative. So the second derivative, if I can find where my cursor is, there it roughly is. That's better. To find the second derivative, what I'm going to do is I'm going to do d dx of each side. Just like when we do implicit, we're doing d dx of each term. We're doing that again because it's a second derivative. That gives me d squared y over dx squared. And now I've got to do the derivative of this right-hand expression, which isn't a product. Whoa, what was that? Getting carried away doing an extra little loop. Negative x over y. It's not a product, it's a quotient. So, what do? We use our quotient rule. Remember, it's going to be, if I have u over v, the derivative of that, u dash v minus u v dash over v squared. We remember our quotient rule. Okay. So let's apply that in this case. So now I'm going to do, so I'm going d squared y over dx squared. The derivative of negative x, so the derivative of the first bit, u dash, derivative of negative x, is negative 1. So u dash v I leave alone, so I leave the y alone. So there's u dash v minus u. I leave the whatever was on the top, whatever my numerator was alone. My numerator was negative x. I leave that alone, and I do d dx of y, because it's the derivative of that. Well, that's just dy dx. All divided by v squared, and in this case the denominator is y, so it's actually y squared. I'm going to move over here over to the left so we can keep going. So how do I make this look like the answer they want? Well, let's simplify what we've got first and see what we've got. D squared y over dx squared. I'm going to have negative y minus negative x becomes plus x. Now, dy dx, we already had an answer for it. It was negative x over y. So let's replace dy dx with negative x over y. All divided by y squared. We can see a problem here. I've got a fraction within a fraction. To solve that problem, I'm going to multiply the top and bottom by y. I'm allowed to do that. That's multiplying by 1. So when I go ahead and do that, I've now got over y cubed, the denominator, that's the easy bit. Negative y multiplied by y is negative y squared. And here I'm going to have negative x squared because the y is going to cancel with the y underneath it. So here I've got negative x squared. Great, we're done. How easy was that? Pretty good. Except that we could pretty this up a bit, couldn't we? If I took out, and you know, that's correct. Let me just say that is correct. But if you go back and look at the answer here, you're going to see they have, where is it? It's that one there, 48. Negative 25 over y cubed. Well, where are they getting 25 from? And why have we just got x's and y's? There's no 25 in it. Let's have a look what they did. If I take the negative 1 as a factor out of that equation there, then what I'm left with is a y squared plus an x squared. Now, if you want to be really nice, you could write it as x squared plus y squared. Doesn't really matter. That's over y cubed. Now, what do we know about x squared plus y squared? If we go back to our original question, x squared plus y squared is equal to 25. So that is where they're getting that 25 from. So I've just got negative 25 divided by y cubed. And that is a second derivative using implicit differentiation, then rearranging it into something that looks nice but it's quite tricky to see the first time. The fact that you guys are doing this is making me really happy. You're doing really well. Keep up the great work. I hope that helps. If you want to see another one, pick another letter. I'll do another one. I'll do another two, whatever you need. Let's just keep up the great work. All right, guys. Cheers. Bye.